So in this video we're going to be tackling factoring polynomials. So let's look at something called the remainder theorem. The remainder theorem. So let's say we have a polynomial f of x. Whatever this polynomial is, when we divide this polynomial by say another polynomial that is x minus a, then we can say that the remainder of that division is equal to f at a. So, what can we do with this piece of information? Well, for starters, we can say that if the remainder, say we do this whole division here, say I have the x minus a, and then I have the whole polynomial here, and then I end up with some remainder, right? Like I have some polynomial, but then at the end I have the remainder, right? So what I'm basically the theorem states that if I was to plug this a into this function here, I would actually get this. However, if you plug if you decide to do the division and get a remainder of 0, then you can say that x minus a is a factor of f of x. If you plug that in and get 0. So this is kind of a shortcut when we start looking at things. So let's try using this theorem to our advantage in an example. Say we have x cubed plus 7x squared minus 2x minus 5, and I want to divide this by x plus 7. So remember, let's say our total like that. So that's f of x. Let's say f of x, say we already factored it, plus 7. And we're left with the quotient plus remainder. Now remember, our x minus a, so in this case a is equal to negative 7 because we're subtracting it. So it's going to be x plus 7 is going to give us a is equal to negative 7. So by that definition of our remainder theorem, f at negative 7 is equal to 0 times the quotient plus remainder. And when I put this negative 7 here, then you'll actually as when you plug -7 into here, you get this 0 here, and then you have this quotient, which is just that. So this entire thing is just going to be f at -7 is equal to the remainder. And that's why we say that f at a is equal to the remainder when you have this. So if you were to actually plug in this number, so let's put that in there. That was just explaining the proof, but if we were to actually plug in f at -7 is equal to -7 cubed plus 7 times -7 squared minus 2 times -7 minus 5. 7 times 7, 49. Well, if you do this in a calculator, you should get -19. So you can just say, based off of the remainder theorem, that we have a final quotient. The remainder is going to be -19, and you can actually do that out if you want to prove it. Just divide these two. Divide this polynomial by this polynomial. You'll find the quotient to be -19. Let's look at another one. Let's go with y equals 4x 4 plus 6x3 minus 6x squared minus 4x. So what I want to do here is find the zeros. So, and we're going to do this or achieve this by factoring. So I see that I can factor a 2x right out the gate. And we've done tons of videos on factoring in the past, so you can check those out. So if we would take out the 2x, we have, I'm going to rearrange this in a way. Actually, no. I'll do that later, step by step. Let's say take out the 2x from the 4x plus 3x squared minus 3x minus 2. So now I'm left with let's see, I can easily factor out, or if I was to rearrange this, let's see, how could I do this? Let us factor out let's do the division. Let's do say we have this already. Let's look at this alone. Let's do 2x cubed plus 3x squared minus 3x minus 2. How could I factor this out in a way? Maybe 2x cubed minus 3x let's try, say if this is f of x is equal to that, f at 1 is going to be 2 times 1 cubed plus 3 minus 3 minus 2. So those cancel, f at 1 is equal to 0, which means, okay, according to our theorem, if x minus a is a factor, it's a factor of this, if, as long as f at a is equal to 0. So that's my shortcut that, not my shortcut, our shortcut in math. So we can say that x minus 1 is a factor, so I can factor out x minus 1, and we can do the long division. So, for the sake of simplicity, I'll just write this here. Let me just do this x minus 1. I have a 2, 3, negative 3, negative 2. If I divide an x out, I should get this will come down, and then I'll have a 2. X times 2 should have 5, 2. So that'll give me 2, 5, 2. Okay. So I should have 2x, x minus 1, and then factored out, we'll have x. So you can find this out using long division. There are other ways to do it quickly, like I did, but we'll probably save that for a different video. It's its own thing. And this, if I was to factor this out, very straightforward. I could do 2x plus 1, x plus 2. That's just by looking at it, I can tell. So there are that's my fully factored equation here. X equals negative 2, x equals negative 1 over 2, x equals 1, x equals 0. Ta-da! Simple as that. So, let's try another one. Well, actually, let's see. Let's see if I can give you guys one to do on your own. And just throw it in the comments. So just do this factor as much as you can. Find it all the zeros. X to the power of 4 minus 6x cubed minus 2x squared minus 12x. X to the power of 4 minus 6x to the power of 3 minus 2